Okay, so here is the last section, 5.5. So, didn't mean to write this. This should be an x squared. But, so for integration, in this class, there's basically just two things. Either you're going to get something that you can just use the list, like in the book, there's just a list of antiderivatives. Like there's the rule for powers of x, there's the antiderivatives of all the trig functions and stuff like that. So if you get an integral and you notice that the function is something from the list, then you know what it is right away. But the other method is U substitutions. If you take Calc 2, you're going to learn a lot of techniques of integration, but in this class, the only real technique we learn is a U substitution. So if you get something that isn't on the list, what you have to do is a U substitution. So here's how this goes. I'm going to define U to be a function of x, and it can be whatever I choose, but some choices are smart and some are not going to lead anywhere. I'm just going to go ahead and tell you what's a good choice for this one, and then I'll discuss how you determine what a good choice is later. What we need to do after we decide what U is I have to write du. And this is, we've done differentials before. This is just a differential. So I do the derivative of this, and then I write dx. So then what's going to happen here, I'm going to write this in terms of u now. So basically what happens is the 2x and the dx, that gets replaced with du. And I'm going to write that in the end. This is the sine of u, right? And then now this is just an antiderivative with respect to u, and this is on the list. The antiderivative of sine is negative cosine. And I should put plus a constant c. Right, and then in the end, since my original integral was in terms of x, I would like to put my final answer in terms of x. And that just means I'm replacing u with x squared again. So there I was able to do the antiderivative of something that was not on my list, and I was able to do it with a u substitution. By the way, why was this a good choice of u? It's because this was inside of another function, and that's often a good choice for you, is to choose something that's on the inside of another function, right? I was doing sine of x squared, so x squared is on the inside of the sine function. So make u something on the inside of something else. So that's probably the biggest piece of advice for how to choose u, is that it should be an inside function. So let's do another one. This one, I see x cubed inside the exponential function. So I'm going to let u be x cubed. Du would then be 3x squared dx. And now let me... Now, this one is just, it's slightly different than the last one, because on the last one, du was 2x dx, and I see a 2x and a dx right there, so that all got replaced with du. On this one, du is 3x squared dx. I see an x squared, and I see a dx. So I see this, and I see this. I don't see a 3. So here's one thing I can do. I can put a 3 here, and a 1/3 here to fix it. So I'm going to keep this 1/3. Now that I have all of this, the 3x squared dx, that's all just du. And this e to the x cubed, that's e to the u. So this is where I'm at now. And this I can do. The antiderivative of e to the u is just e to the u. And, oh, whoops, I forgot something. I shouldn't have written these numbers. This is a definite integral. It has numbers on the bottom and top. The last one was an indefinite, so we didn't have this issue. This one is a definite integral. When you make a u substitution on a definite integral, your original numbers are going to change. Your original numbers are values of x. We need to replace those with the corresponding values of u. So, oh, yeah, after all of this talk, I think I just realized these aren't going to change, because u is x cubed, so the new top limit, I'm going to plug in 1 for x. So the new top limit is 1. The new bottom limit would be 0 cubed, which is 0. So like I said, they actually didn't change, but that's just a coincidence because 1 cubed is 1 and 0 cubed is 0. But you have to change, in general, you have to plug these x values in to find the corresponding u values. When I write the new integral in terms of u, these should be values of u. Anyway, I get to this point, and now I'm just going to plug these numbers in directly for u. 1/3 e to the 1 minus 1/3 e to the 0. E to the 1 is just e, e to the 0 is just 1. So I get 1/3 e minus 1/3. Okay. Let's do another one. Maybe let me go ahead and make this a definite integral, and actually I'd like to make sure that the same thing doesn't happen. So let me do this. So let me give you the second piece of advice on how to choose u. I said the first piece of advice is to just choose u to be the inside of a function. And this new piece of advice is not so different. If you have a fraction, let u be the denominator. So then du would be 3x squared dx. So, okay, what do I have here? Again, I have a similar issue from last time. Du is 3x squared dx. I see x squared and I see dx, but I don't have a 3, but I can put a 3 and a 1/3. So now that I have that, 3x squared dx, that's just du. And everything in the top went into that, so now on the top I just have 1. The bottom is just u. And these limits, the new top limit would be, because u is 1 plus x cubed, so 1 plus 3 cubed would be 28. And the new bottom limit would be 1 plus 2 cubed, which would be 1 plus 8, which is 9. There we go. The antiderivative of 1 over u is natural log absolute value of u. So this is 1/3 natural log of 28 minus 1/3 natural log of 9. Okay. Let's try this one. I'm going to follow the standard advice. U is going to be something on the inside. It's the inside of the square root. Du would just be, the derivative of this is just 3 dx. And, right, so let me take this and start trying to piece it together here. I have, this is definitely the square root of u. I don't know about this dx, and I don't know about this x. I would like to replace these things, but it's not clear where everything's going to go. So here's something you can try to do to make it work, even if it doesn't look like it wants to work. You can start solving for the things that you need to replace. I need to replace dx with something. I can look here. Dx would be 1/3 du. So this dx gets replaced with 1/3 du. I also need to replace this x. I can solve for x here. So 3x is u minus 2, x is u minus 2 over 3. Right? Okay, so this is good. Whenever you're doing a u substitution, you want to get rid of all of the old variable. The old variable's x, the new variable's u. I don't see any x's here, so that's good. What I need to do is now I need to try to integrate this. And this one's not so easy, but so I have this 1/3, and the 3 in the denominator here is like another 1/3. So I can say 1/9 because I can pull a constant outside of the integral. And then it's u minus 2 times the square root of u, which let me change that to u to the 1/2 power. Okay, so the situation is improving, but what I would really like to do is multiply this out to get all the powers of u. So I'm going to have u times u to the 1/2 is u to the 3/2 minus 2 u to the 1/2. So I multiplied this out. Now I can use my standard power rules here. This is 1/9. Let me put brackets so I remember to distribute everything. This one would be u to the 5/2, and then I'm supposed to divide by 5/2, but let me take a shortcut, and instead of dividing by 5/2, I'll multiply by 2/5. Then minus 2, because this 2 carries right down, and then I should have u to the 3/2, but I'm also supposed to divide by 3/2, which is the same as multiplying by 2/3. And I should write plus c. And then finally, let me clean this up a little bit and put my final answer in terms of x. Okay, 1/9 times 2/5 would be 2/45. U to the 5/2 would be 3x plus 2 to the 5/2. This would be 1/9 times 4/3, which is 4/27. And then it would be u to the 3/2, which is 3x plus 2 to the 3/2 plus c. All right. So, right, just remember you may have to do things like that to make your u substitution work. You may have to solve things, you may have to solve for x, you may have to solve for dx. Let's do another one. So for this one, let me call this a first try. I could follow some advice from before. I said let u be the denominator of a fraction, so I would let u equal x. But let me tell you something, this is never going to be a good idea. Letting u be the same exact thing as x is never going to be helpful. Let me show you what happens. Du would just be dx, right? Derivative of this is just 1, and you're doing times dx. And then this turns into, let's see, u is the same as x, so the top is just natural log of u. The bottom is just u. Dx is just du. Basically, all that happened is I wrote the same exact thing, except all the x's just changed into u's, which makes perfect sense. That, like the substitution I made is where x and u are the exact same thing. So all that happens is the letter x changes to the letter u. But that doesn't make this integral any easier, right? We haven't made any progress towards solving it. So this is not going to work, and this happens sometimes. The truth is, u substitutions are a bit of an art in the sense that there's no guarantee of like what will work. You have to try things and see if it works. So let's try something else. And this is not necessarily following any particular advice I can give you. I'm just picking something else out of the equation and saying, well, what if I let u equal that? Maybe if we start to think about what du is, then we will start to piece it together. Du has an x in the denominator, just like this x in the denominator. So actually, what happens here is this turns into the integral of, let's see, the top is just u. The du is 1 over x dx. So if I write du here, that takes care of this x in the denominator. So actually there's nothing else in the denominator to take care of. So in other words, this is just integral of u du now. That's like u to the 1, and I just use the power rule, so u squared over 2 plus c. And then that's, I should put my final answer in terms of x. So u was natural log x, so I put that in. So, right, I mean, it's a little scary, but, I try to give you advice that's as applicable as possible, but you may have to just try different things. The advice that I'm giving you, it's not guaranteed to work all the time, and it's not possible for me to give you advice that'll work all the time for u substitutions. I'm not going to be cruel to you. I'm not going to give you a u substitution that is incredibly hard or comes from nowhere, but you do have to be willing to try things. There's no cookie cutter way for me to tell you how to solve every problem for u substitutions. You may have to just try some stuff. Let's do one more. But it helps. It helps to be able to think one step ahead. Now, let's talk about this one. Of course, sine cubed, that's the same as if I put parentheses around sine and then cubed on the outside. So then sine would be the inside and cube would be the outside function. If my advice is to to pick the inside, so then I would let u be sine, because that's sine is on the inside of the function that is cubing it. But before I go and write du, let's try to just think about this in our heads. Du is the derivative of this. That would be cosine, and I like that because I see cosine. A good u substitution or, you know, you can tell it's going to be a good u substitution if you can see du already. This is how you can, you know, without doing a lot of work, this is how you can sort of tell the difference between a good idea and a bad idea. So what this is just u cubed du. Because cosine x dx, that was all just du. Yeah, so that's 1/4 u to the 4th plus c. So that's 1/4 sine to the 4th x plus c.